Hello class, and welcome to today's algebra lesson, which is about absolute value functions. By the end of today's lesson, you will be able to identify transformations of these functions, as well as write the equations and graph those functions and find their domain and range. An absolute value function is a specific type of piecewise function that ends up being shaped like a V. If you remember from the beginning of the year, absolute value tells you how far a number is away from zero. So the absolute value of 5 is 5, and the absolute value of -5 is also 5. So when I plug in the number 5, 1, 2, 3, 4, 5, and I go up 5, that's a point on my graph. If I go to -5, that's also a point on my graph. It's two different parts. It's a piecewise function because one of these parts is facing one direction with the slope. So this one has a negative slope, and this one has a positive slope. So it's got the two different parts of the graph. The parent function of an absolute value function is f of x is equal to the absolute value of x. So that's straight up just equal to the absolute value. That's the simplest form that we can have. The modified format, when these transformations are going to happen, is f of x is equal to a absolute value of x minus h plus k. So that's where we're going to start transforming our function around the graph. The vertex is the highest or lowest point on the graph. In this original function, my vertex would be down here at 0, 0. The formula for the vertex is the h value for the x and the k value for the y. Because the parent function has no x value, the original vertex is 0, and there's nothing being added, so 0. So that original vertex is 0, 0 of all absolute value functions. The transformations are going to move it around. We're going to start with the translations. These are the h and k values. If there is a plus k on the end of the expression, that is going to move the value of the graph up. If it is minus k, that is going to move it down. If it is going to move horizontally, subtracting the h is moving it to the right, and adding the h is going to be moving it to the left. So if we do a couple examples here, we're comparing it to the original parent function, which is the absolute value of x. For g of x here, I've got the absolute value of x minus 3. Since there's a number being subtracted on the end, that means your function is going to move down 3 units. If I look at this next example, I have x plus 5 inside those absolute value bars, which means I am going to be moving left 5 units. And then this last example is a double movement because I've got something inside and outside those absolute value bars. Subtracting the 11 is going to tell me that we are moving right 11 units. And then the subtracting the 17 outside the bars is going to tell me that we are moving down 17 units. So you are looking similar to those linear equations. Are you adding or subtracting? Is it inside or outside those absolute value bars? Go ahead and identify the translations for this one on your own. 7 units right because of the minus 7. The plus 2 tells us 2 units up. So now what does that actually tell us when we're trying to write the equation? When we are writing the equation, I am looking at this vertex point. So this vertex, this point that the absolute values come to, tell me what the values of h and k are. So my vertex, remember, is in h, k format. So in this case, my h value is 1, 2 to the left, which is a -2, and 4 units down. So our vertex then is at -2, -4. So what does that look like in the equation? Remember, we have for our equation, we're going to have f of x is equal to, inside the absolute value, it's going to start with x. That -2 tells me that I'm moving to left. So that's going to be a plus 2 inside the bars. And then that -4 tells me that I am moving 4 down. So my equation for this function is f of x is equal to the absolute value of x plus 2, and all of that being subtracted by 4. Go ahead and try this one on your own. So your vertex is moved 5 units left and 3 units up, so your function is f of x is equal to x minus the absolute value of x minus 5, all increased by 3. The next piece is looking at the dilations. That's what happens when we have this a value in the front of your expression. Once again, similar to the linear equations, we have vertical and horizontal dilations. If it is a vertical dilation and it is outside of those absolute value bars, anything bigger than 1, so the values bigger than 1 are going to be your vertical stretches. Once again, that's going to make it taller. And anything that's between 0 and 1 is going to be your vertical compressions. That is what is going to make the graph look flatter. So it's having it go up or down, taller or flatter. The horizontal, the multiplication is going to happen inside of those absolute value bars. So that x is going to be multiplied inside the absolute value bars. When that happens, we have, and it is bigger than 1, we have a horizontal compression. So we get it narrower. Our value, the v of that graph is narrower. And when it's between 0 and 1, it is going to be wider. So once again, this is the same stretch piece that we had with the linear functions. So the rules for linear functions when you were multiplying, whether it was bigger than 1, smaller than 1, inside or outside the pieces, is going to apply to these absolute value functions. So if I have, again, my parent function of f of x is equal to the absolute value of x, if I have the 3 on the outside is telling me that it is going to be a vertical change. And because the number 3 is bigger than 1, that is going to be a vertical stretch of this absolute value function. If I look at the second one, and I've got the 2/7 x inside the absolute value bars, the inside tells me that it's going to be horizontal. So we've got that inside the bars is our horizontal values. And then because it is a fraction, so it is between 0 and 1, this is going to illustrate a horizontal stretch. Then for this last one, I've got a fraction, but is now on the outside, which tells me I'm moving back to vertical. And then a fraction or something less than 1 outside of the bars tells me it is a vertical compression. Go ahead and try this one on your own. Inside the bars, multiplying by a value greater than 1 is going to be a horizontal compression. The last piece is our reflections. If I have a reflection and that value is on the outside, so it is a negative number outside the parentheses, this is going to be a reflection over the x-axis. So it is going to take the original graph, which was shaped like a V, and it is going to flip it over and have it be shaped like an upside down V. So it flips over the x-axis. If the negative is on the inside of those bars being multiplied with the x, it is going to flip over the y-axis. So it is going to shift left and right sides of the equation. So now we're going to put the dilations and the reflections together. So we can immediately tell all of these are reflections because they have a negative sign with them. So it's not just going to be vertical or horizontal, it's also going to look at those reflections. So I'm going to start by saying, okay, this is a value that is outside my bars. So this is going to be a vertical change when it comes to the dilation. So we have a vertical, it's bigger than 1, so I've got a vertical stretch, and we have a reflection because of the negative over, and because that negative is outside of those absolute value bars, it's over the x-axis. When I look at the next one, I now have my values on the inside, so this is going to be horizontal. Because it is a value between 0 and 1 on our horizontal, it's going to be a stretch. And then because our negative is on the inside as well, it is a reflection over the y-axis. So it's going to flip our values over that y-axis. Last example here. We have, once again, the value is on the inside, so it is going to be horizontal. The number is now bigger than 1, so it's going to be a horizontal compression. It's going to be getting narrower. And once again, our negative is on the inside, so it's going to be a reflection over the y-axis. So we've got our value, our negative number is on the inside, so it's a reflection over the y-axis. Go ahead and try this one on your own. So we've got a reflection over the x-axis because the negative is on the outside, and then it is a vertical compression because we are looking at a value smaller than 1 on the outside. So now when we graph these, we want to be able to state the domain and range of the function as well. So I'm going to start by graphing. The important piece here is to be able to pick out your h and your k values. So when we look at this, I've got x minus 7, which tells me I am moving right 7. So my first part of my vertex is going to be 7. And then this k, this negative 3, tells me I'm moving down 3. So my vertex is going to be at 7 to the right and 3 down. So that is going to be my initial value that I am going to put onto my graph. What I can then do is look at the a value out in the front. So in this case, I just have a negative sign, which means I just have -1 in front of my graph. So that's going to tell me my slope. That's going to tell me what I'm counting by, which in this case is going to be down 1 and right 1. This is going to build up the right side of your graph only. So I've got the right side filled in. Absolute value functions are symmetrical, so because you have the right side, you can then fill in the left side by going opposites. So we've got our values there, and then you are going to connect your dots by going one line to the right and one line to the left as far as we can possibly go within our graphs. And then we want to make sure once again that we have those arrows on the end to say that they continue going. So we'll do another example. Oopsies, I almost forgot to go over the domain and range of these functions. So the domain, once again, is the numbers that you can plug in. Similar to the other piecewise functions we have looked at, the domain is all real numbers. We can plug in any value for x. Our range then, we are looking for how high or low those values can go. The vertex is the key here. So the vertex, your y value of your vertex is -3. If you look at this graph, it's going below that point, so your y values are going to be less than or equal to -3. Moving on to this next example now, once again, we want to pick out our vertex to start. So the x plus 4 in the absolute value bars means that you should be moving 4 to the left. The -1 outside means that you should be moving 1 down. So your vertex is at -4, -1. So 4 to the left and 1 down. Your slope then for this one is 1/3. That tells you how to build up the right side of the graph. So by going up 1 and right 1. So we go, up 1 and to the right 1, 2, 3. Up 1 to the right 1, 2, 3. Then we've got to build up the symmetric part of the graph. So if I go up 1 and right 3 to start, I would go up 1 and left 3, and then up 1 and left 3 again. So we build that left side up using symmetry to the right side. Once again, you want to connect your dots with a straight arrow going all the way through the end of your graph to both the right and the left. And you want to make sure you are putting your arrows on the end to say that those lines keep going. Once again, for our domain, we have that all real numbers can be plugged into this function. So your domain is any possible value of x. Your range then for this one, we go to our low point in this case, which is -1. The graph is going above that -1, so we're going to have our range as y is greater than or equal to -1. Go ahead and pick out the vertex to this problem and graph it on your own. So our vertex is 1, 5, 1 to the right and 5 up. That slope on the right side tells me to go down 2 and then right 1 and repeat that pattern. Then you're going to mirror it over to the left side, which gives you the resulting graph. Now I want you to go ahead and state the domain and range on your own. Once again, the domain is all real numbers. Your range, since we have a high point, all of your y answers are occurring under 5, so your range is y is less than or equal to 5. If you have questions about this or anything else from the lesson, please feel free to reach out and let me know.